Design of an analog Butterworth low-pass filter. The specifications are given. When you compare this question with the previous one, you will find that they have given the gains instead of the attenuation. In the last question, they have given you alpha p and alpha s, but here in this question, they are given just the gain, which is modulus of h of g omega, as well as omega p and omega s. Now again, we have to find out the values of epsilon and lambda using these formulas. The formula for finding epsilon is 1 divided by root of 1 plus epsilon square, and same way 1 divided by 1 plus lambda square for finding out the value of lambda. So just equate these values, solve it, and get the values of epsilon and lambda. Meanwhile, we'll just draw the frequency response of the Butterworth filter. As you can find, it is monotonous. It's a monotonically decreasing function. As omega increases, you can see that the gain is dropping. The passband frequency omega p and stopband frequency is omega s. The maximum gain will be 1 at 0 frequency. And according to the question, the gain is 0.9 at omega p, and at omega s, the gain is 0.2. Generally at omega p, you will have the gain value as 1 divided by root of 1 plus epsilon square, and at omega s, you will have 1 divided by 1 plus root of lambda square. And that is the value that you are required to find. So solving these two equations, you'll be able to get lambda and epsilon. We also mark the value for omega p and omega s as 0.2 pi and 0.4 pi respectively. To solve for 1 and 2, take square on both sides. So finally, we've got the values of epsilon and lambda. These values have to be substituted in the value and formula for n. So using this formula, we can get the value of n. So solving, we'll be getting the value of n as 3.34. Next step is to round off this to the next highest integer, which is 4. Then we have to write down the transfer function. So we know the transfer function of h of s. Divided by s square plus 0.765s plus 1 into s square plus 1.847 is plus 1. Next, we need to find the cutoff frequency omega c given by omega p divided by epsilon whole power 1 by n. We know the value of n, we know the value of epsilon, omega p also. Just substitute all these values and get the value of omega c. Now substitute s equal to s by omega c in h of s to get the modified transfer function. Therefore, the modified h of s will be, so wherever s is there, just replace that with this value, which is s divided by 0.24 pi in our case. Just simplify this. And 323 divided by s square plus 0.577s plus 0.0576 pi square into s square plus 1.393s plus 0.0576 pi square. Thank you.